Hey everybody, welcome. We're going to spend today a really brief lesson just kind of reviewing linear equations to get us ready for one of our next units. So let's get started. We're going to answer this today. What are linear equations and how do they operate on a coordinate plane? A lot of this should be prior knowledge for you, but I think it's worth us like spending a day on it. What we're going to eventually do is prove the slope criteria for parallel and perpendicular lines and use them to solve geometric problems. So this is our next standard that we're going to be working on, and this is why we need to understand linear equations. All right, let's get started. So these two equations are given in standard form. We're told to put each equation in slope-intercept form, which is y equals mx plus b. I bet you're familiar with that. And then state the slope and the y-intercept. Okay, let's back up for a second. Anytime you have an equation, like the ones we see here, where you have x to the first power and y to the first power, and they're not being like multiplied or anything, that's a linear equation. So this is going to be a straight line on the coordinate plane. Every straight line on a coordinate plane is going to have a slope and is going to have a y-intercept. The fastest way to figure those out is to put our equation into the y equals mx plus b format, because the slope we can easily pick out and the y-intercept we can easily pick out. So let's do that here with number one. What I want to do here is I want to isolate the y variable. So I'm going to subtract 6x from both sides. So now I've got 3y equals negative 6x plus 12. And then I'm going to divide by 3. And make sure I divide everything by 3 to keep it all even. So it's going to be y equals negative 2x plus 4. All right, so from here now that I have it in the slope-intercept format, now we can see that the slope is negative 2, just that number right in front of the x. And then our y-intercept is going to be 0, 4. It's just 0 on the x value, 4, because that's what was in our b value. Okay? You can pause it here and try the next one on your own if you'd like. I'm going to go through it here now. So we'll subtract 5x. Again, I'm just trying to isolate the y variable. So I have 7y equals negative 5x plus 14. Now I'm going to divide by 7, get the y alone. Make sure I divide everything by 7. So y equals negative 5 over 7. Okay to leave that as a fraction. X plus 2. So in this problem, our slope is negative 5/7, and our y-intercept is 0, 2. I just plugged these lines into Desmos to check to make sure that we did it correctly, and here we can check by seeing that our y-intercept is 0, 4, and then we're going down 2 over 1, so I kind of missed on that one, down 2 over 1, down 2 over 1, so our slope is negative 2, and then here our y-intercept was 0, 2, and I kind of cut the graph off a little too early, but we should be able to go down 5, over 7 to get to our line here. So Desmos, as always, is a good resource to check your work. Okay, this is what you should add to your notes. Y equals mx plus b is slope-intercept form. A linear equation is an equation between two variables that reveals a straight line when graphed. That's why it's called linear, right? A linear equation. We prefer it in the y equals mx plus b format because we can easily pick out our slope and we can easily pick out our y-intercept value. These equations represent every xy coordinate on the line. So an equation of a line in slope-intercept form, it's giving you every single point on the line in that single equation. Because whatever x value you plug in, you'll get a y value out of it. All right, now let's take a look at what happens when you change different parts of these equations. So let's talk about what happens when you change the b value. If you change the b value, you're going to move your line either higher or lower. So here, first let's look at y equals 1/3 x, the first equation. There's no b value, which means the b value is 0. So that means this is referring to this line here, right? Because it's going through 0, 0, and its slope is 1/3, up 1 over 3. We can see that. Now look what happens when we write the same equation, but we add plus 4. We have the same line, but we just moved up 4 units basically. Now we're hitting the y-axis at 4, and then our slope remains the same. So as you can see, changing this to changing the b value is going to move your line higher or lower. If we had like y equals 1/3 x minus 4, right? You'd have a line that was going down somewhere like this, hitting -4. All right, what about changing the slope? Changing the slope is going to affect the line's steepness and its direction. So 2 different things could happen. So here's 3 equations. Let's try to match each one up. Notice how they all have a common y-intercept. They're all hitting 1 or 0, 1 on the y-axis. So the only thing that's different about them is their slope. So let's start with a negative slope. And how does a negative slope look compared to positive slopes? So here we go, -1/3. That means that from left to right, the line has to be decreasing. The only line that matches that is this one here. Okay, so putting a negative in front of your slope is going to make your line decrease when looking at it from left to right. So we know that one is the first one. Okay, next one here, y equals 3x plus 1. Notice how we went from -1/3 to 3. The larger this number gets, the steeper it gets. So as you can see, this is not a very flat line. It's like going up at a very steep rate. And that's how we know that that's y equals 3x plus 1. You know, we can also see the slope if we wanted to count it out. All right, finally, y equals 1/10. The smaller that number gets, so 1/10 is a pretty small fraction, that means you're going to have a flatter line here. So you're going to get a line that's flatter the more small that this number gets, this fraction. So that's why it makes sense that this would be our 1/10 line, our third line here. Okay, so changing the slope is going to change the steepness, and it can also change the direction. Notice how both of these lines were increasing as we went from left to right. That's why they had positive slopes. All right, just a quick peek at like where we're heading. We're not actually going to do this problem, but I just want you to see. Eventually, you're going to be shown a picture like this, and you're going to have to say, all right, this is a rectangle. What are the equations of each line from this rectangle? So what lines kind of like encompass this rectangle? What contain the rectangle? So eventually you're going to be able to do things like that. So kind of connecting what we were learning with what we are going to learn. Couple extra practice opportunities. You can do some practice problems on Khan Academy. There's also another little overview if you want to see another video. And today is not an exit ticket. It's an important little difference. It's a Desmos activity that you have to complete. Okay, make sure after you complete it, you click done on Google Classroom, so then it'll mark it as complete. I also am going to look at the activity and check out your work there, but it's mainly just for you to kind of like get comfortable with linear equations again. So have a good time with it, and talk to you soon.